Hello, this is video number 1 for Unit 5. We've had an introduction to this unit in class, but before we get going on today's video, what I'd like you to do is on your notes make sure you've tried the warm-up problems. There are 4 warm-up algebra problems, followed by 4 questions, and then a section for you to fill in some identities from your formula sheet. So I'd like you to pause the video and then go ahead and try the warm-ups 1 through 9, and then come back and see how you did. Okay, I trust that you tried those warm-ups. Let's go through the algebra ones first, since they are first on the page. The first 2 questions remind us about the difference of squares pattern. And so for question number 1, you should have x plus 3 and x minus 3 as the 2 factors. They can be in either order, either the plus or the minus can be first, but you do need to have both. And that comes from doing FOIL in reverse, okay? The inner and outer terms here would cancel out, which is why you don't have something like 6x or something in the middle there, okay? The next problem, again, a difference of squares, is going to be 4a for the first 2 front terms, and you're going to have 5b for the terms in back, and then 1 plus, 1 minus. It does not matter which order, but you need to have one of each. The next 2 problems are both what we call perfect square trinomials. It just means that you have 3 terms, it's a trinomial, and that you're going to have the same factor as it turns out. So to get the x squared, we would need an x and an x. To get the 1, you need a 1 and a 1. And then you have positive 2x in the middle. So to get that term, you have 1x plus 1x equals the 2x in the middle here. And then the last factor in question is very similar to the previous one, except the degrees of the exponents are different. The degrees of the terms are different because of the exponents. So x to the 4th is x squared times x squared. For 1 in the back, you'd have a 1 and a 1. And then because the middle term has a negative sign, you'd have a minus with a minus. Now it turns out that that is itself difference of squares again. So this first parentheses can be broken down into 2 separate factors, x plus 1, x minus 1, and then this term is also, again, x plus 1 and x minus 1. So that factors to 4 complete separate factors. The next few questions remind us how to deal with fractions. Question 5 and question 6, you both should have the same answer. You need a common denominator. You need to have the same bottom in order to add or to subtract fractions. Okay, in order to multiply fractions, like say you have one fraction times another fraction, you go straight across the top, straight across the bottom. So however you want to represent this to yourself. The idea is that you go straight across, not crisscross. And to divide fractions, say you had something like this. We divided fractions a lot in the graphing unit, like when we were doing the period formula or figuring out the horizontal shift. You guys probably all know that you multiply by the reciprocal, okay? And then you go straight across, like we talked about in the previous one. Oops, I wrote something wrong there. That should be A over B. A over B times D over C, okay? Okay, so flip this one. Take the reciprocal. Okay, and switch the division sign to multiplication. The next page are the identities that I referred to in the introduction. And so these are all the important identities from your formula card. In today's lesson, we're just going to be using a few of them. The Pythagorean identities are going to come up. This first Pythagorean identity comes from the unit circle. So if you go back to your unit circle and you think about, okay, I have a reference triangle here. Inside that reference triangle, this side represents the cosine, this side represents the sine, and this side is 1. So sine squared plus cosine squared has to equal 1 squared, and that's what this is saying. 1 squared is just 1. The other 2 Pythagorean identities can be derived from that first one. We'll talk about this in class at some point, I'm sure. But both of those come from the first Pythagorean identity, and the first Pythagorean identity is related to this unit circle, okay? Some other identities that will be used in today's lesson will be this tangent identity gets used. We used this back in the unit circle days. Tangent is sine over cosine, and we certainly will use that today. We also will see some of the even and odd identities. So some of these functions are what are called even functions, in particular those two. Even functions are symmetric to the y-axis when you graph them, and that means that the cosine or the function value of a negative has to equal that same function value of a positive. And then the odd functions are these and these. Okay, so the ones I put a purple dot next to. So 4 out of those 6 statements work so that you have a negative here, and that's equivalent to having a negative on the outside. So a lot of students think of that as you pull the negative out for the odd functions. The even functions, it doesn't even matter if you have a negative versus a positive inside the parentheses, so to speak. Reciprocal identities we should be pretty familiar with. Those are just which things are reciprocals of each other. And cofunction identities we talked about way back when, but at that point these pi over 2's were 90s because we were dealing in degrees. But you have in fact seen those before way back in a different unit. Okay? Let's work 4 problems. That's all we have to do, 4 problems. In these problems, notice that we are dealing with expressions, not equations. That's important because sometimes people think we're solving. We aren't solving here. We are simplifying. When you simplify, you just rewrite. You don't try to find out what x is. We can't do that. We don't have something, 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 equal sign, something, something, something. That's not the format. We just have one thing on one side of the equal sign, okay? Not something is equal to something else. All right, so in this problem, I look at this, and it says to simplify, I notice sine over cosine. So I look at my formula sheet, and the formula that comes to mind is the identity that I have. I'm just going to try to put a different sort of mark by it, but maybe I'll use the same kind of mark as before. This one. Tangent of something is sine of that thing over cosine of that thing. So I have here my angle is negative x. This is just going to equal tangent of negative x. Okay? And then I have to think, well, can I do anything else with that, or is that as simple as it gets? And I realize my angle is negative, which makes me think of this area, because all of these involve a negative. Check out right here. Tangent of negative theta equals negative tangent of theta. So I can just pull out that negative and make the angle itself positive. That's what that last statement said. And I don't think that can get any more simple than this. This is pretty compact, and I am done. The hardest thing with these questions, I think, is figuring out if you're done or not. This next question reminds me of factoring. Like if I had a to the 4th minus b to the 4th, I would recognize that as a difference of squares. And I would factor it a squared plus b squared, a squared minus b squared. And then this itself might have some more simplifying to do because it is also a difference of squares. Here, let's try using that idea, okay? This looks a lot like this. So I'm going to write secant squared plus tangent squared and secant squared minus tangent squared. Those are my 2 expressions. Now, I remember seeing some things on that formula card that had a lot of stuff with squares. Remember seeing that? It was in the Pythagorean identity section right here. So I'm going to see if I can find something that would be of use. The one that I think is going to be useful here is this one. And the reason I think it's useful is that my problem had secant and tangent in it. So I noticed that secant squared is tangent squared plus 1. So I'm going to come over here and say, well, secant squared is right here and right here. And what I just read is that secant squared is the same as tangent squared plus 1. So I'm going to put in place of the secant squared, tangent squared plus 1. This is just following along. And then in place of the secant squared, I'm going to put tangent squared plus 1. And then this part's just going to follow. So this was here before. Okay? It's just following along. So I replaced the highlighted secant squareds with tangent squared plus 1. Now check this out. I have 2 tangent squares. 2 tangent squares. And then I have a 1. And over here, really cool, I have a tangent squared and a minus tangent squared. Those add up to 0 plus a 1. When I multiply this first parentheses by the 1 doesn't matter, so I don't really need that. Something times 1 is itself. And that's going to be my final answer, because I can't think anything else to do with it. I think it's as simple as it gets. The next question, I'm going to make use of this guy again. Tangent is sine divided by cosine. And I'm going to replace this tangent right here with sine over cosine. Everything else, I'm just going to follow along from how it was before. So the only replacement I made was the tangent squared. Now, right here, how do I deal with this algebraically? Well, I think I could make this a fraction by going like that. And then I could write sine squared over cosine in place of the stuff with the blue box on it. And then this other cosine is just dropping down. And then I need to remember the warm-up. The warm-up said if I needed to add things that were fractions, I needed to have a common denominator. So over here, I'm going to multiply by cosine over cosine. Now this is legal because the writing right there in black is equal to 1. And multiplying by 1 doesn't change anything. So now this part is cosine squared over cosine. And I just carried that first fraction along. My handwriting is so horrible on this. You guys are troopers to put up. Okay, then look at this. I've got a common denominator. So I can go ahead and add those fractions. That common denominator is just going to stay there. And I have sine squared plus cosine squared. Now that rings some bells. Maybe not for you yet, but for me, that part on the top that I'm highlighting is super famous. Look back at our identities. Where is it? Do you see it? It's right there. It's right here. Yeah. Sine squared plus cosine squared equals 1. Think about that unit circle. Think about that reference triangle. So I know the top part I highlighted in yellow is actually 1. The bottom is cosine. What is equal to 1? Oh, that is just horrible writing. What is equal to 1 over cosine, guys? Look back at that identities page while I fix this. What is 1 over cosine equal to? Did you find it? It's right here. 1 over cosine right here is secant. You know that those are reciprocals. Secant is the reciprocal of cosine. And that, my friends, looks very simplified. One function, nice and easy. The last one also boils down to some factoring. I can factor tangent to the 4th to be tangent squared times itself. And the 1 in the back here is a 1 with a 1. And to get 2 tangent squared, I'd have both of these be positive. This question is supposed to be a lot like this warm-up question here. Right? X squared plus 2x plus 1. Sort of like this. It's a little bit like this one too. Right? X to the 4th minus 2x squared plus. Kind of like that. Just that you have tangents instead of just plain x's. Okay? Now, tangent squared plus 1. Oh, we should be so excited. Look at this. Right here. Tangent squared plus 1 is secant squared. Hot dog. So this part is same as secant squared. And this part is another secant squared. And if you have something like a squared times a squared, I hope you know that that's a to the 4th. So these two together are going to make secant to the 4th. Right? This is secant times secant. This is secant times secant. So altogether we have secant multiplied by itself 4 times. And that is as good as it gets. Okay? So hopefully that helped you. Take that along with all the examples we did in class, and hopefully you have a really good idea of how we use identities to simplify. I will see you tomorrow or the next day at school, whenever that might be, for some more work on this. Thanks so much.